So inner product is just another name for the dot product. So we've already talked about dot product. This should not be new. We're just going to also call it inner product. So U dot with V is just going to be the sum of the products of the corresponding entries. In other words, you just multiply the corresponding entries together and add them up. So here I get 6, this is negative 10, this is plus 3. It's like this one's negative 1. Now, you could think of this as matrix multiplication. So this is 3 by 1, this is 3 by 1. If I were to say multiply U transpose times V, U transpose would be 1 times 3, or 1 by 3, and V would be 3 by 1, and what you would get would be a 1 by 1 matrix, which in this case is just going to be the single number, negative 1. So what does this look like? So if I transpose U, just make it a row vector, and leave V alone, and say you just take the dot product of this row and this column, which we just did, and we got negative 1. So it's like you get a matrix that's 1 by 1, but we're just going to call it just a number. Okay, so that's all it is. It's just dot product, but you just think about it as matrix multiplication. All right, the length of a vector is how long the vector is, okay? And if we think about in 2 dimensions, what does that mean? So let's say this is the vector AB. And you could make a triangle, right? You could say, well, this is B high and A across, okay? So this side is A, this side is B. So this side from Pythagorean theorem would be the square root of A squared plus B squared, okay? So the square root of A squared plus B squared. And we're going to use the same concept no matter how long the vector is. So we use a special notation, these double brackets. Looks like double absolute value. This is called the length or the norm. Sometimes you call it the norm of the vector, or you can think of it as magnitude. Just how long it is. It's going to be the square root of the individual entries squared. And then you add them up. So in our case, we have 3 entries. So this will be 2 squared plus negative 5 squared plus negative 1 squared. So that's 4 plus 25 plus 1. That is the square root of 30. And I don't think that reduces any. So the norm of U, or the magnitude of U, is the square root of 30. So let's do it again for V. Magnitude of V be 3 squared plus 2 squared plus negative 3 squared. So 9 plus 4 plus 9, that is square root of 22. That doesn't reduce either. So there are the lengths. Now, if you think about what this is, right? This 3 squared plus 2 squared plus negative 3 squared, that's 3 times 3, and that's 2 times 2, and this is negative 3 times negative 3. Well, that's just, if we look at V, that's just V dotted with itself, right? So V dotted with itself is kind of its magnitude squared, and then you take the square root of that and you get the magnitude. You get the length. So in general, the magnitude of a vector is the square root of that vector dotted with itself, or inner product, if you want to call it inner product. This says find two unit vectors in the same direction as u and v respectively. So what does it mean to be a unit vector? It means that the length is 1. So unit vectors have length 1. So first we need to find the lengths of these two. So we just did that on the last one, right? So we got the magnitude of u is the square root of 30, and the magnitude of v is the square root of 22. So let's think about it in 2 dimensions. If I have a vector, we'll call it u, and then the length of it is the magnitude of u, okay? We want a vector that's in the same direction but has length 1, right? So we want the vector to be pointing the same way as u, but we just want the length of it to be 1. So all we have to do is take the magnitude of u and divide u by that magnitude, and that will scale the vector down so that it has length 1. So remember, when you multiply by a scalar, you are scaling the vector, right? So we just need to multiply u times 1 over the square root of 30. So that will divide each component by root 30. And that will shorten the vector down till it has length 1. So this is 2 over root 30, negative 5 over root 30, negative 1 over root 30. We're going to be really interested in unit vectors later on. So this is why we're learning this now. Okay, for v, I need to multiply by 1 over square root of 22. And that'll be 3 over root 22, 2 over root 22, and negative 3 over root 22. Now let's just check this and see. Let's just find the magnitude of this vector. So I'm going to take the square root of, and I'm going to square each component and add them together. So if I square this guy, I'm going to get 4 over 30, right? If I square the square root goes away. If I square this guy, I'll get 25 over 30. And here I get 1 over 30. If I add those together, I get the square root of 30 over 30, which is the square root of 1. So we get 1. So that you can see how that works there, right? If you divide by the magnitude times the vector, it's going to scale it down so that the length becomes 1. So if we want to find the distance between two vectors, and we're going to denote this as distance uv, we're going to take the magnitude of the difference, okay? And you could see in 2 dimensions, remember the parallelogram rule, we'll call this u and this v. The sum is this diagonal, right? So this diagonal is u plus v. The off diagonal, this guy, is u minus v, and that would give us the length of this vector will give us the distance between u and v. So we just need to take the magnitude of that. So that's all it is. It's this parallelogram rule. One diagonal is u plus v that we talked about a lot. We didn't talk about this one as much, but take the off diagonal, the other diagonal, it's u minus v, and that'll be the distance between the endpoints of these two vectors. So we just need to find the magnitude of u minus v. So let's just do u minus v. What is that? So 2 minus 3 is -1. -5 minus 2 is -7. -1 minus -3 would be -1 plus 3, so it'd be 2. And I just need the magnitude of u minus v. That'll give me the distance. So square root -1 squared plus -7 squared plus 2 squared. So that's 1 plus 49 plus 4. Square root of 54. That one does reduce because 54 is divisible by 9. It's 9 times 6. Square root of 9 is 3. So I get 3 root 6 is the distance between u and v. So what are orthogonal vectors? So let's start with a formula that you learned in trig class. And it involved the dot product and the magnitude. So you've kind of done these things before. Or maybe you don't remember, or maybe you didn't do them in 3 dimensions or higher, but the concepts are the same. If you remember this formula, if you had, say, vector A and vector B, the dot product of A and B is equal to the magnitude of A times the magnitude of B times cosine of the angle between. Cosine of the angle between. And if you were trying to find what is the angle between the two vectors, you would divide both sides by the magnitudes, and you would get this formula. Okay. Orthogonal is just another word for perpendicular. So if two angles are perpendicular, they have they form a 90-degree angle between them, right? So they have a 90-degree angle between them. We use perpendicular when we're talking about R2 and R3 vectors. Okay, you can measure angles, you get 90 degrees. Orthogonal is just a term that kind of extends it to higher dimensions. So you can't really say that fifth dimension vectors are perpendicular because it doesn't make sense. We can't draw or even imagine a fifth dimensional 90-degree angle, right? So we just say they're orthogonal if they have the same property. And the property is going to be this. Notice that if I plug in 90 degrees or pi over 2 radians in for theta, cosine of that angle is 0. So if the angle between them is 90 degrees and they're perpendicular, this is equal to 0. And a fraction is not equal to 0 unless the numerator is equal to 0. So we would say two vectors are orthogonal if their dot product is equal to 0. So and we'll say if and only if. If two vectors, if their dot product is 0, they're orthogonal. If they're in R2 or R3, then we can say they're perpendicular as well. Okay, but the general term will be, from now on, will be orthogonal. So let's see if these two vectors are orthogonal. We're just gonna, these are the same two vectors we've been using. We're just going to take the dot product. U dot V. I think we did this already. I don't remember what it was, so we'll just do it again. Just taking the dot product. Whoops. plus 3. And that looks like -1. Yeah, that's what we got before. So the dot product's -1. That means that these vectors are not orthogonal. Okay. Now, we could then find the angle between using this formula. All right, let's just go ahead and do that. What is the angle between them? Well, u dot v over magnitude of u times magnitude of v is -1, because we already did the dot product, and square root of 30 times square root of 22. And that's going to equal cosine of theta. So let's open up a calculator, and we'll see what the angle between them is, because we know it's not 90, because it's not orthogonal. They're not orthogonal to each other. I'm going to change this to degrees. I'm going to say cosine inverse of -1 divided by the square root of 30 times 22. You can put those together like that. That's kind of a, if you multiply two square roots, you can multiply what's inside and keep it under the square root. So this is 92 degrees. 92 degrees. You'd want to verify this in a, you'd want to graph these and verify it, because cosine inverse, sometimes it doesn't give you the angle. It'll give you a coterminal angle. So an angle that's equivalent in another quadrant. So you want to check it and make sure. I'm just going to say it's about 92 degrees for now. If I'm wrong, you'll let me know. Okay. What about C and D? Let's take the dot product. So 4/3 times 5, -1 times 6, 2/3 times -1. So that's 20 over 3. -6 would be -18 over 3. And this is -2 over 3. That's 20 minus 18 minus 2. That's 0 over 3. So these are orthogonal. So C and D are orthogonal. U and V are not orthogonal.